Okay, we're going to be learning about calculating the area of all kinds of geometric shapes in this unit, and this first one's easy. We're doing area of a rectangle and area of a parallelogram. Um, for both of these, you're doing the base, which is the side that the in this case rectangle or parallelogram is sitting on, that full length right there, times the height, the vertical height that forms a 90-degree angle. Um, and you can see that if you had if you removed this section right here and you filled it in over here, you would just have that length appearing over here. You'd have the exact same base from here to here and then there, and the same height as though you were doing a rectangle. So you can just do the base times the height. Now you can see here, what are we using as an altitude? When we call an altitude, we say we're dropping a vertical line straight down from this top side to the base. In a parallelogram, you can say that this is the altitude if we're sitting on this side, but you could also be sitting on this side and this is the altitude. I've made this rotatable, so check it out. We can take this and rotate it around like that, and now it's sitting on that red side as the base, and of course the altitude is the vertical height here, straight up and down from that top side. Now you could drop it there, you could do it inside it. Either way, you're going to get a 90-degree angle forming with the base, and so that becomes your altitude. Since these lines are parallel, then it doesn't matter where you do it to get that altitude. Okay, that's the big idea for that. Now let's apply it to a few problems. Okay, so what's the area of each of these parallelograms? You notice we have three measures here. We have this here, base of 5, this elevation of 4, and then we have this side length of 4.5. Which measures do we use? Well, watch this little bit right here, okay? The altitude, why do we consider this 4-inch side the altitude, or this 4-inch measure here? They must be perpendicular to the base. This side right here, 4.5 inches, is not running perpendicular to the base, and we always need our altitude to do that, okay? So what do we calculate here? Well, let's do this one first. We do base times height, 5 times 4, and we get 20. And since the units are inches and we're doing inches times inches, is inches squared, so 20 inches squared. Here we have this altitude of 3.5. We have this base of 2. 2 times 3.5 is 7. So we have an area of 7. The units are centimeters. And so we did centimeters times centimeters is centimeters squared for the units. Okay. Here's your got it problem. You're going to try it, and you're going to pause the video now, and you're going to come up with your answer, and then you're going to check it against my answer. Okay. What is the area of a parallelogram with a base length 12 meters and a height 9 meters? Pause the video now and get your answer, and then unpause it. Okay, so let's just sketch this out. Here we have our parallelogram. And they're telling us that it's a base of 12 meters. And the height, the vertical height here, the altitude of 9 meters. So what's 12 times 9? That's 108. And meters times meters is meters squared. So we have an answer. The area of this parallelogram is 108 meters squared. Let's see what else they got for us. Okay, so they've given us this figure here at the right, and they're asking us what is the length of DE, this altitude, for this parallelogram to the nearest tenth. Okay, we could do this if we knew what the area equaled. We could say this base of 9.4 inches times this height of, we don't know, let's call it x. Put an x in here. If we knew what it equaled, then we could solve for x then, but how would we figure that out? Well, they gave us other measurements here. Check it out. Just reading along here. Okay, first find the area of this parallelogram ABCD. How do we do that? Well, if we were to rotate this thing and put it on its other side as the base, you could see then it's got this base length of 13 and this altitude of 9, okay? And notice this little bit that they put in here, okay? What is CF? CF is that altitude. If we were to set it right on this base, we would need a 90-degree angle running up to the top. That's the altitude right there, okay? So we calculate it here, we plug it in, base times height, 13 times 9, 117, and that is what the area of this parallelogram is. So once we know that, we can plug that in and say, okay, if we know that it's 117 and we have a base of 9.4, then we can figure out what DE is equal to. I called that X, okay? So how would you solve for DE? Well, you would divide by 9.4 because that's the coefficient of it. And this is approximately equal to 12.4 when rounded to the nearest tenth. So DE is about 12.4 inches. How did you know it was inches? Because they gave the area as inches squared, or we calculated it as inches squared because that's the units that we're using. Okay, so here's your got it problem. A parallelogram has sides 15 centimeters and 18 centimeters. Height corresponding to the 15 centimeter base is 9 centimeters. What is the height corresponding to the 18 centimeter base? You're going to want to sketch it out and do the calculations just like we did here, problem 2, and pause the video. And when you unpause it, you can check your answer against mine. So pause it now, calculate the answer to this. Okay, so if we know that we have an altitude of 9 centimeters from the 15 centimeter base, then we can say the area is going to be 15 times 9, which, fun fact, is 135. And that should be equal to, in the other direction, we have a base here of 18. And what is the altitude? 90-degree angle up to the other opposite side. Well, that's what we don't know. So we can say that it is 18 times x. So 135 equals 18x. And of course, you need to divide both sides by 18. And what you get is 135 divided by 18, which is 7.5 centimeters. So in this direction, we would have an altitude. Let's see if I can draw it for you. You would have an altitude of 7.5 centimeters. That's how you do that. Okay, so to come up with the formula based on the formula for area of a parallelogram, you can take this triangle, take a look at this triangle here on the left, and it says you can rotate the triangle about the midpoint to form a parallelogram. And I actually have this copied, and when you see when I rotate it, if I fill it in right there, we're getting a parallelogram that's got a base of B and an altitude of H. So base times height would give you the area of this. But the original triangle was only half of that. You can see that we doubled that in order to do that. So the area is half the area of the parallelogram, 1/2 base times height. It's a way that you can visualize what the formula is for this, okay? So there's your theorem. Area of a triangle is 1/2 the product of a base and a corresponding height. And the base of a triangle can be any of its sides, and the corresponding height is just the length of the altitude to the vertex of that highest point, making a 90-degree angle. Okay? Let's apply this. Okay, so this one is just a little bit more mathematically rigorous, and you've got to pay attention to what we're doing here. Okay? This says you want to make a triangular cell like the one at the right. How many square feet of material do you need? You notice that they're giving us the measurement in a combined feet in inches, right? That altitude is 12 feet 2 inches and its base is 13 feet 4 inches. We need to be able to convert this to the same units, okay? You can see right here. Why do we need to convert the base and the height into inches, which we're about to do? Because we can only multiply measurements with like units. So first we're going to convert it. We're going to say, okay, if we take this 12 feet part and we know that 12 inches is equal to 1 foot, so this is an equal amount, we're multiplying by a complex form of 1, okay, 12 inches over 1 foot. And that will cancel the units feet. 12 times 12 is 144. That should make sense to you. 12 feet, each being 12 inches long, would be 144 inches. Plus these 2 inches is 146. That's what this converts to into inches. Okay. Same thing on here. We're taking these 13 feet and we're multiplying that 13 by 12 to find out how many inches those 13 feet are. Okay. And what we get is 156 plus these extra 4 is 160. Okay, so we can now say if it's 1/2 base times height, we can take the base of 160, we can take the height of 146, and we multiply them together, and we get this number of square inches. But we don't want this to be in square inches. They say how many square feet of material do we need, and we have this in square inches. So we need to figure out how many square inches in a square foot. And fact is, I can just sketch this out for you really quickly, and then I'll show you what they did. But imagine this is a 1 foot by 1 foot square, and it's actually 12 inches by 12 inches. So what's 12 times 12? It's 144. So every group of 144 square inches is going to equal a square foot. Now, what we're doing here, they're using the method of converting, where they say, okay, we're going to now take this inches squared, and we're going to end up turning it into square feet by saying 1 foot is equal to 12 inches, so 1 foot over 12 inches is a complex form of 1, and we're going to do that twice. We want this inches squared, or inches times inches, to cancel out. That cancels this inches, and the other one here cancels this one. Okay, and then you get feet times feet, or feet squared. When you do this, dividing this by 144, it works out to be 81 1/9 square feet. So you have 81 1/9 square feet of material. You can see that the fraction was simplified, and you could write this out. There's some students that struggle with fractions. If that's you, you can ask me how to do this again, but I'm not going to assume that you struggle with fractions. This is something that you should know at this point, so I'm going to treat it as though you know it. You're going to need to seek out the help individually if you want a little more support on that. Okay. What's the area of the triangle? You're going to do the same thing that we did in problem 3 right here. You're going to pause the video. You're going to solve this. You're going to come back and check your answer against my answer. So pause the video now. Try this Gotta problem. Okay. So what we want to do is let's convert this into inches. Notice that they do not ask us to give them the area in any particular form. Up here in problem 3, they said how many square feet. They wanted this in square feet. Here they're just asking what's the area of the triangle, and they're not asking for it in square feet. So that's convenient for us, although I'll show you what it would be if it was square feet. So we say 1 foot, that's the same as 12 inches. So if we do the area is equal to 1/2 base times height, and the base is 12 inches, and the height is 5 inches. Then calculating this out, we have 1/2 times 12 is 6, 6 times 5 is 30, and inches times inches is inches squared. So the area, and this is a perfectly fine way to leave your answer, the area is 30 inches squared. Okay? But if you wanted to convert that into square feet, you can say, just like you did here, where you say 1 foot is 12 inches, we can also do this by using 1 square foot is 144 square inches. So we can take this 30 inches squared times 144 inches squared equals 1 foot squared. You can see how these units, inches squared, are going to cancel out. So we'll be left with feet squared. And 30 over 144, we can simplify down. And I'll do this up here. Okay. 30 over 144. You can do this in parts. You can say, okay, I'm going to first just divide it by 2, and we get 15 over 72. I see that those both divide by 3. So 15 divided by 3 is 5. And 72 divided by 3 is 24. And so you could say that that is equal to 5/24 of a square foot. But since they didn't ask you what, or they didn't tell you what unit they wanted it in, then keeping it in this answer right here of inches is probably your best bet. Okay, one more problem, we'll be done with this first lesson of Unit 10. Problem 4, finding the area of an irregular figure. There's no one clear figure that this is, but as you can see, there is a triangle part and there is a square part. And if we calculate the areas of each section separately and just add them together, then we'll have the area of the whole figure. So if we look at the triangle area, we say it's 1/2 base times height, so it's 1/2 6 times 8. How do we know that this base is 6? Well, as you can see here, as they mention, this is a square. You can see these segment marks say that all of those are equal, and since this is 6, that makes this 6 as well. So even though it's not labeled, you should be able to identify that as 6 inches. Okay, so 1/2 6 times 8, and notice this, if you took 1/2 of 6, just doing this piece first, you'd get 3. 3 times 8, 24. You could also have taken half of 8. What's half of 8? It's 4. So then do 6 times 4 is 24. You just got to be careful not to take half of both of them, because taking half of that and half of that, really, you're only going to get a quarter of what you wanted instead of half. Okay? But you can do half of either one of these numbers, and then multiply them together, you get 24. That is for the triangle part. Now, what about here? The square isn't 1/2 base times height, it's just base times height. It's a rectangle. Okay? 6 times 6, 36. So if we add those two amounts together, we get 60 inches squared. So here's your got it problem. Suppose the base lengths of the square and the triangle in the figure above are doubled to 12, but the height remains the same. How is the area of the figure affected? You're going to try this got it problem. I'm going to suggest that you make a sketch of it and pause your video now, solve the problem, then unpause the video and come back and check your answer against mine. So pause the video now. Okay, so I'm going to sketch this out where they say they want you to keep the height at 8 inches, but they're going to double the base. So instead of it being 6, it's now going to be 12. 12 by 12. Yeah? So if we do, for the area of the triangle, 1/2 the base of 12 times the height of 8, we would get what's 1/2 of 12? It is 6. And then what's 6 times 8? It is 48. So we get 48. The units were inches, so it's inches squared. And then for the area of the rectangle, we've got just base times height, or 12 times 12. And that is 144 inches squared. And so the area of the entire figure, when you sum these, just that, we still get inches squared. The units stay what they are. And you get 192 inches squared. And that is the area of the figure if you were to double the base but keep the height the same on that top triangle. Pretty straightforward, yeah? Hopefully this first lesson is nice and easy for you, because you're going to need to spend the rest of this week preparing for your Unit 8 test, which is going to be on Monday. So do this lesson, do the IXLs that are with it and the book problems, and then you're a couple of homework problems that you're going to submit, and spend the rest of your week studying for the Unit 8 test, which will be Monday at 1 p.m. Good luck.